Okay. Let's see if you guys can see this. Let's really start us off nice. What's the square root of 25?
5.
Okay, so what's the square root of 50? Can I do that?
No. 2 times.
So tell me this first. Can somebody give me a good estimate of the square root of 50? What number is it close to that I can do the square root of?
25. 25
What number is 50 close to?
49.
49. So isn't the square root of 50, it's got to be a little bit more than 7? Because that's a little bit bigger than 49, which square root would be 7. All right, so that's not good enough, though. I want an expression that's exactly this, just a little bit better. And it's a lot like if you gave me an answer of 8 over 14, why would I not give you full credit?
You reduce it.
You're supposed to reduce it. It's the same idea as what's going on here. This radical is not reduced. That might be the first time I use that word, by the way. I've got to be careful about definitions. We call this a radical sign. So if you ever hear me say rad 50, I'll be careful with that. Normally I say root 50. Or root. So square root of 50, I can reduce it because 50 has a piece of it that can be square rooted.
5 times 2.
Yeah, 50 is 25 times 2. And if I do what we just did here in reverse, break it back up, isn't this square root of 25 times square root of 2? You guys with me? Because this would be 50, of course. What's the square root of 25? 5. What's the square root of 2? I don't know. Careful. It's not square of 2, the square root of 2, I don't know. So it kind of makes sense. If I can't do the square root of 50, I can't. I better be left with something that I can't do anything with, right? But there's a piece of 50 that I can do something with.
It's going to be 5 and something. So it's going to be 5 and something you need?
Well, it's going to be 5 times square root of 2, which is 1.414, blah, blah. Yeah. So it'll still be the 7 point whatever, right? When you do this, it'll still be the 7 point whatever that we estimated from up here. How are we doing there? So that's kind of nice. I like to relate this to this. It's like that's the right answer maybe, but you haven't reduced it yet, right? Same way that might be the answer, but you didn't reduce it. So how would you do this one here? Which one, Jeff? I don't know. Yeah. So do you, yeah. So do you see a plan of attack? One direct plan of attack is divide 28 by things you know work. So I'm not going to divide 28 by 2. I can't do the square root of 2. I'm going to divide it by 4. Because I can do the square root of 4, right? And sure enough, 28 is 4 times 7. So break that up. Square root of 4 is 2, and square root of 7, I don't know. Okay. So both of us, me and you, have to be careful about coefficients versus roots, right? Like if I want the cube root, don't let it kind of drift down and become a 3. You know what I'm saying? If you have a cube root of 7 and you keep writing it and it becomes like this and then it becomes, oh crap. It's supposed to be cube root of 7, but now it's 3 square root of 7. Oh shit. So be very careful about not forgetting these guys or letting them drift to the front. That sucks. Math is hard already. Don't make it just because you keep it organized, right? What about this here? What? Oh, yeah, let's go. So yeah, 27.
Oh, no.
What about 27? So you want to break it up. What numbers can you do the cube root of? Can somebody give me a couple numbers you can do the cube root of?
27 times 3.
You can do the cube root of 27, right? What's the cube root of 27?
3.
3. And 27 does go in 81, right? Somebody give me a couple more numbers you can do the cube root of. At least one more number you can do the cube root of.
9 and 18?
No.
Not related. Why can you do the cube root of 27? Because 27 is 3 cubed.
Right.
All right, well, what's 2 cubed?
16.
What's 2 cubed?
8.
8. So you can do the cube root of 8, can't you? What's the cube root of 8?
2.
2, because it takes 3 2's to make 8, right? Do you guys see what I'm saying? So what might be a really good idea, and in fact I think one of the homework problems says this, is make a list of cubes. And you guys might remember some of those numbers from when we did the difference of sum of cubes. We had to be able to break it up into 3 parts, which is really what we're doing here, right? That's what a cube root does. It breaks it into 3 parts. We went as far as 5 cubed. We saw some 125s in there, didn't we? So if I saw the cube root of 125, that's 5. You might want to do the same thing with the squares. Hopefully we're a lot better with squares. At least up to 12.
Yeah.
So how do I do this then? I can break this up as 27 times 3. Because 8 does not go into 81. What's the next cube up? 27. Oh, 27 goes into it 3 times. Kick ass.
Yeah.
So now I can break this up.
27.
What's the cube root of 27?
3.
3. What's the cube root of 3?
I don't know.
I don't know. I like it. Bunch of 3's everywhere, right? 3 coefficient, 3 root, and 3 on the inside. Yes, you did, but a little too soon. I wanted to bring everybody with us. All right, here. You guys try these. I've been talking too much. Let me shut up for a minute. You guys, pay attention to what I just said. So how do you do this first one here? How do you break it up?
125 times 2.
Good. Let's hoping that you remember what we just talked about. Cube root of 125 is 5. And the cube root of 2? I don't know. So you do the part you can do, you don't do the part you can't. That kind of makes sense. What about this guy?
Square root of 49.
I love it, right? Square root of 49 is 7. The square root of 2, I don't know. Cool. So really quickly, go with me for a second. Little side note. I want you to see the relationship here. If I have 11 over 8, I can't reduce that, but can't I do a part of the 11 divided by 8? I mean, I can make this a mixed number, right? 11 is 8 plus 3. So I can do the 8 divided by 8, but I can't do the 3 divided by 8, right? So I get 8 divided by 8 is a whole 1, and then the 3 is left. Square root of 49 is a whole 7, and the 2 is left. It's very similar, right? If only this would have been 8 over 8, I would have had nothing left. If only this would have been square root of 49 without the extra stupid 2, I would have had nothing left, right? I like the analogy between these things. Square roots work with multiplication the same way that division works with addition. Okay. What about number 3? I wanted to throw you a little bit of a curveball.
X squared
1 x squared
times
or x.
Don't overthink it. I haven't done anything with variables yet, so I want to give you an easy one with variables. What does it take 3 of to multiply to be x cubed? X. That's it. Now it gets worse if it was the cube root of x4. That would kind of suck, wouldn't it? We're not quite there yet, so we'll hold off on that. And of course, what about this guy here? Yeah, that one's kind of a gimme. Because 88 can definitely be divided by 8, which is one of our cubes. So I rewrite that as cube root of 8, cube root of 11.
Yeah.
Cube root of 8 is 2. Cube root of 11, no idea. Okay, all right. So let me do one thing here. Let me see if they do something freaky. No, good. Oh, there it is. Okay, they do something freaky. So let me talk about that right now. Let me do that example, what to do when you have like x to the 4th in here. Then I'll show you a little bit of a preview, and then we'll have my customary early leaving, especially this tomorrow's. So if I did, now cube root of x cubed is x. Cube root of x to the 4th, how many extra x's are in there?
1.
So I could do it like you guys try to do this one. I could break it up into a part I can do times a part I can't. And you guys just told me there was an extra x in there, right? Yeah. So if I write it in terms of my x cubed that I could do beautifully times this stupid extra x there, just throwing me off. What's the cube root of x cubed? X. And what's the cube root of x? I have no idea. Now here is, you can always do these like this. Here is a kick-ass shortcut. I desperately hope that you understand the shortcut, because it's going to make all these problems so much easier when you have variables in there. 3 goes into 4 how many times? Not times. 3 goes into 4 how many times? Once, with how many left? 1. 1 left, right? So if I had, for example, the 4th root of a7, 4 goes into 7 how many times? Once, with 3 left. And doing it the other way, when I write this a4 times the extra 3a's that I have, do you see that if you wanted to? 7 is 4 plus 3. 4th root of a4 is a, right? And the 4th root of a cubed, I don't know. I get the same answer either way. So let me do a couple more shortcuts. Oops. So what if I had the cube root of 8a 6b 11? So you do them like you always have. You do the numbers, and then you do the variables as they come. Okay. What is the cube root of 8? 2. Okay, good. So we got that piece done. 3 goes into 6 twice with any left over?
3.
None left over, right? And why does this make sense? If I broke a6 up into 3 parts, wouldn't it be a squared, a squared, a squared? So a squared. Right. The shortcut kicks so much ass. 3 goes into 6 twice. You can only do that with exponents though. Right? And really the reason that works is because when I have a squared cubed, what do I do here? Multiply. So when I do the cube root, I'm doing the opposite, so I will divide. It only makes sense. 3 goes into 11 3 times with 2 left over. You can make it 2. There you go. No, you can't. There you go.
What do you do with a 2 from left over from the 8?
It's not left over. Cube root of 8 is 2. So the parts that are out here are the parts that I could do the root of. And that's why they're whole stuff. They don't have any roots on them anymore, do they? Because the cube root of 8 is 2. There's no numbers left. 3 goes into 6 twice. There's no A's left. 3 goes into 11 3 times, and there's a couple left. Because only if this would have been a 9, it would have worked fine. There are 2 extra B's, well, they get stuck. They get left behind. Do you see that?
Where's the 9?
Where's the 9?
No?
Yeah, right here. If this would have been a B9, but it's not. It's a B9, and there's a couple extra B's, aren't there?
Yeah.
Isn't it 11,
Yeah.
9 plus 2?
Yeah.
So 3 goes into 9 3 times, and those 2 are left. Right?
Just extend that, but so it's 3 into 8.
Ah, yeah, but
You did it like that, and
you can only do this with exponents, right? Because exponents, what do they do when you have something with an exponent to another exponent? What do you do with the exponents? You multiply them. That's why when I do a root, I divide them. When I have a number raised to a power, I just raise it. So, watch this. Look at cube root of 8 by itself. How can I rewrite 8? Well, it would be 2 to the third power. You guys with me? 2 cubed is 8. Now, since I wrote it in the same form as these, it will work the same way these would. 3 goes into 3 once with none left over, right? There's no remainder. 3 goes into 3 once. And we know the cube root of 8 is 2. So it's the same thing as we had before. Numbers do not work the same as powers do, right? And we saw a problem. I saw a lot of people doing this. Remember this kind of problem here? Let me make this, 12 over 10A4. What I saw a lot of people, not a lot thankfully, but a few people doing was, what do you get for the A's? What happens here? Subtract. So you get A squared. And then I had somebody put a 2 there. Where do you think that 2 came from? Because they did 12 minus 10. Numbers don't act like that. Exponents act like that. Not numbers. So up here, numbers don't have 3 going to 8. 3 doesn't even go into 8. That sucks. Exponents act like that. They don't act the same because they're not the same things. So the actual thing here, you have to reduce this, right? So it'd be 6 over 5 A squared. Okay. So last thing. Just to kind of show you why we want to be able to do stuff like this and like that. And then here's another question, like, what's your gut tell you? Believe it or not, your gut is going to be right in this section more often than not. What's your gut tell you about? Now I'm hopeful. I'm hoping that what I just said is true. 3. Yeah. Because what is square root of 7? I don't know. I don't know what the square root of 7 is. Is the correct answer, right? You can kind of give me an estimate. Square root of 9 is 3, so it's a little less than 3, right? But that still ain't an answer. I don't know what it is. So 1 of these plus 2 of these is 3 of those. So it acts just like, I don't know what the hell x is. Plus 2 of the same thing makes 3 of the things I don't know, right? So this thing I don't know plus 2 more things I don't know makes 3 things I don't know, right? It's awesome. Kicks so much ass. What do you think is true then about, since it works a lot like variables, what's this? was trying to get somebody's attention at the door, and I'm
Five.
staring him down. He's gone away now.
3 to 75.
7 times 5.
So this is something plus 2 of something else. This is a lot like x plus 2y. Can you do this? So I can't do that. Are they like terms? No. Oh shit, they're not like terms. Right? I can only add like terms. These are like terms. Why? Because they both have square roots and they both have a 7 inside, right? So they are like terms. These are not like terms. This is 1 square root of 7 plus 2 square roots of 5. I can't put those together.
So not real?
No. That's already simplified, right? It's a real number. It's just an ugly real number. So here you go. Here's the ultimate thing here. Here's why we had to do what we did over there. So if I said square root of 7 plus square root of 28. Now based on what I just said, can you do anything with that the way I gave it to you? What can you do?
7 times.
Okay, good. What I was trying to get out of you is no, you can't, because these are not like terms, but you can start to make them like terms possibly, because you can break this down, right? Square root of 7 plus 28 is 4 times 7. And see how these are really nice. They give you a hint. I want to divide 28 by this, because I want that to be left inside, so they'll be like terms. So I get square root of 7 plus, what's square root of 4? 2. What's square root of 7? I don't know. So square root of 7 plus 2 square root of 7 is 3 square root of 7. So they started off as not like terms.
Yeah, wait, where did the 3 come from?
Okay?
1 plus 2.
I have 1 root 7 plus 2 more root 7s.
Oh, okay.
So I have 3 root 7s. So that's why I said it acts just like as if it was x plus 2x. This plus twice this is 3 of this. Cool. I like it. So let me give you one to try, and then we'll head out. I know it seems like I keep adding stuff, but
No.
just because I am. Let's see. See if you guys can handle this here. Can you handle it, Jeff? Are you willing the clock to move? What superpower manifest? Time. So how can you break up root 50?
Okay, 2 times 25.
All right.
And minus 2, 19 times
2 times 9.
I like it. So, just taking this really one step at a time. This will be root 25, root 2, minus twice root 9, root 2, right? Just breaking them up.
Yeah.
So root 25 is
5.
5 root 2 minus twice 3 root 2. So I have 5 root 2 minus 6 root 2. I like it. Whatever number's out front already, it's just going to multiply by whatever you're able to get out, right?
Yeah.
Let's choose multiplying by this. Square root of 9 is 3, so 2 times 3 is 6. 5 root 2 minus 6 root 2 is
Minus 1.
negative root 2. I love it. Okay. Have a good Thanksgiving.